Properties of magnetic lines of force. While proposing the concept of lines of force, Michael Faraday argued that if all the observed effects are to be explained satisfactorily, then the lines of force must have certain properties. Now, let us study the properties of magnetic lines of force. Magnetic lines of force are imaginary connecting lines, and Faraday introduced the concept of lines of force in order to explain the magnetic attraction and repulsion. Second, magnetic lines of force always run from north pole to the south pole. The south pole may be of the same magnet or a different one. Third, magnetic lines of force are in a state of tension like a stretched spring. Fourth, magnetic lines of force repel each other. Fifth, magnetic lines of force they do not intersect each other. And sixth, the number of magnetic lines of force at a particular point determines the strength of the magnetic field over there. So you can now see from the figure how the properties given above help to explain the repulsion between like poles, attraction between opposite poles. According to the third property, the lines of force joining north and south poles of a magnet being in a stretched state like a spring pull the two opposite poles towards each other. And by the fourth property, they give rise to repulsion between like poles. Penetrating ability of a magnetic field. Here in this activity, what you can do is spread some pins on a table, hold a cardboard at a small distance above these pins. Place a bar magnet on the cardboard and observe. Now move the magnet slowly over the cardboard and observe. Repeat this procedure, increasing the layers of cardboard and observe. What you observe is, in spite of there being cardboard, the pins get attracted to the magnet. In the second activity, fill water in a plastic bottle, drop a few pins in the water, take a bar magnet near the bottle and observe. Move the magnet through a small distance near the bottle and observe. So here also you observe that even in water the pins they get attracted towards the magnet. So from the above observations we see that a magnetic field can pass through cardboard, it can pass through a bottle, it can pass through water. So what difference is there is the intensity. The intensity of magnetic field is found to decrease. Use your brain power. What is meant by magnetic force? The force of attraction or repulsion between the poles of the magnet, or the force by which magnetic substances are attracted towards the magnet, is called magnetic force. How does a magnetic force act without direct contact? Magnetic force is produced due to the magnetic lines of force. Magnetic lines of force start from north pole and end on the south pole. Therefore, these lines of force are spread in the region around the magnet. Because of this, the magnetic force can act up to a certain distance from the magnet. Thus, a magnetic force acts without direct contact. Next question. What is the difference between gravitational force and magnetic force? Gravitational force acts on any object which has mass. There is only attraction and no repulsion in case of gravitational force. Whereas the magnetic force does not act on an object. It acts between magnet as well as magnets and magnetic substances. And in case of magnetic force, both attraction and repulsion take place in the magnetic force. Can you tell what is an electromagnet? If you remember last year in the chapter Fun with Magnets, you had studied how to make an electromagnet. Okay, you just wind a piece of wire around a nail, iron nail, and connect it to a battery, and you find that after some time when the current is passing through the nail also starts behaving like a magnet. If you bring iron nails around another iron nails around it, it starts attracting, so it starts behaving. So that is magnetism when electric field is present, and such magnet which is made in presence of electric field is called an electromagnet. How can an electromagnet be made? It can be made by passing electric current through any conducting material. For example, here you can have used an iron nail. Metal detectors. The function of the machines. You have all observed these metal detectors. They are there in various public places or stations. The function of these machines is based on electromagnets. Metal detectors are used in very important places like airport, bus stations, certain temples and buildings. They are used for inspection of persons entering these places. Metal detectors are used to detect very precious articles, and also uh, in food processing industry to detect any iron or steel objects mixed unknowingly in foodstuffs, as these would be harmful to health. In geology, these machines are used to detect the presence and quantity of metals. Use your brain power. Why is repulsion the real test for identifying a magnet? See, children, if there is an attraction between two objects, we can say that both the objects are magnet, because one of them can be magnet and the other object can be substance like an iron. However, if there is attraction between the ends of these objects, and after keeping an end of one object unchanged, the end of the other object is changed, and if the repulsion takes place between these two ends of the objects, we can surely say that both the objects are magnets. Because there is a repulsion between like poles of magnet and attraction between unlike poles of the magnet, hence repulsion is the real test for identifying a magnet. How will you find a magnet from among the various articles given to you? If various articles are given to you, first you will take a bar magnet. Bring its any pole near both the ends of each object given. If there is a attraction between both these poles, then we understand that the object is not a magnet but it is a magnetic substance such as iron, nickel or cobalt. If there is no attraction between both the ends, then we can identify it is a non-magnetic substance. If there is attraction at one of the end and repulsion at the other, then the other object is magnet, because repulsion is the real test for identifying a magnet. Thank you.